Hi there. Welcome to part 12 of the Wireless LAN Security Mega Primer. So this is where now things are going to get a little bit more hot, and in this video we will talk about man-in-the-middle attacks over wireless. So let's understand what we really mean by a wireless MITM. Now there are different cases about how we can conduct the MITM attack. Let me take one of them first. So let's consider a simple architecture in which there is an authorized access point with an SSID security tube which is connected to the internet at the back end, and there is a victim connected to this authorized access point. Now for the sake of simplicity, let's assume for the time being that the access point security tube is open authentication and no encryption. We'll come to what can be done when encryption such as WEP, WPA, etc. has been applied in later videos. Now, you must be wondering when he's saying later videos, how many more? It's already the 12th. So by my calculation, this series would at least be 22 videos. Right? So hope you have the patience to go through the entire series. Right? So coming back, now in the same vicinity, you have a hacker who in this scenario is connected to the internet, maybe via a wired connection. And what he's going to do is also advertise a honeypot AP with SSID same as the authorized access point, which is security tube. Now we've looked at how to go ahead and kind of break isolated clients, and we actually know right now that even though this is connected to the access point, this is a simple hotspot based attack in which we first de-authenticate the connection between the victim and the authorized access point. The connection breaks, and if we have enough signal strength, which is the hacker machine, the victim will now connect back to us. From this point onwards, any traffic the victim sends for any host on the internet would be going through the hacker's laptop, and this is the case of a man-in-the-middle attack where the hacker is in between the victim and any website or application server the victim is trying to access. So this is one scenario. In another scenario, what we could do is maybe the hacker does not have an internet connection directly, and what he would do is first the victim would be connected to the access point. He would break this connection, have the victim connect to him, and in turn he would connect back to the authorized access point. This way all traffic the victim sends or receives goes through the hacker to the authorized access point and towards the internet. So this is another variation of the attack. The third variation is basically when the hacker has a GPRS 3G or 4G card, using which instead of actually having to be stationed with a wired connection or connect back to the authorized access point, he can simply relay the traffic to the internet over actual wireless connection using GPRS 3G or 4G, depending on whatever is available. Right? These are these three variations. The core concept of how to go about this hack remains the same. Now let's look at our setup, which we will create right now. What we are going to do is kind of a simple hybrid setup which will give you a taste for everything. The victim is connected to security tube to the internet, and in this case the hacker is advertising the spurious security tube SSID. He is in turn connected to the SSID Vivek access point with SSID Vivek, which has access to the internet. Now if I would like to simplify this, I might just have the hacker connect here and send traffic through this one, but I just wanted to take a little bit more complicated setup to kind of show you the basic principles. Now we will concentrate on this setup only, and depending on the hardware access you have, you can have a look at the other setups as well. If you have any questions, please post them. If a lot of people are having issues with other setups, I may create a video and post it here. So in this case, what would happen is the hacker breaks the connection, which is the trivial part, and the victim connects back to him. Now, for the sake of simplicity, we've already taken care of this part in a previous video where we actually disconnected the victim from the hotspot and had him connect to us. So we will not repeat that part of the experiment. Instead, all we will try to do is to lure the victim to connect to the hacker and then transparently do a wireless man in the middle attack. So the question arises, how does this hack actually work? So before going to it, I just wanted to make you understand and aware about what needs to be done. So here is the setup where the victim is advertising the SSID security tube. Now this could be an SSID which it could have figured out from the victim's PNL, like in the previous video where we had seen of how to break into isolated clients, or this could also be an SSID which is actually belonging to a hotspot in the same vicinity to which the victim is connected. Now, after the victim gets disconnected from the authorized access point in the hotspot attack case, or maybe the victim is just searching for the security tube network, what ends up happening is eventually the victim connects to the hacker machine. Now, this part of the connection, if you remember, is what we create using our alpha card over the Mon0 interface, right? Now, the next question arises, how does the attacker connect to the other access point? Now, typically, almost all laptops have inbuilt Wi-Fi. And inbuilt Wi-Fi, even though it might not at times, depending on the driver availability, support things like packet injection and packet sniffing very well, what it does great is basically connect to another access point, right? This is something which is very stable and would practically work for any inbuilt chipset. And this is what we are going to use, but with a little twist, because in our case, we are running Backtrack 4 inside VMware, which actually means, well, we do not have direct access to the wireless card. Simply because VMware or VirtualBox currently does not support the inbuilt Wi-Fi chipset to be exposed to the guest machine inside it. And this is where what we will do is, using VirtualBox or VMware, whatever you're using, we will actually map the wireless interface which is connecting to the SSID Vivek to ETH0, which is exposed inside VirtualBox. And then we will bridge both of these interfaces so that any traffic sent by the victim to Mon0 would straight away go to ETH0 and to the internet, and any traffic coming from the internet towards the victim would once again be relayed over the bridge. Phew, a lot of theory. Now let's come to the actual action. So we talked about two things, right? The first thing is, in the setup, is we have to map our internal Wi-Fi card to the ETH0 interface inside VirtualBox. So the way we do it is, if you notice, I am already connected on my MacBook Pro to Vivek, which is a network available to me. Now, what I do is, in the VirtualBox setting, under network adapter, I actually set it to NAT. Please note, the only interface which is up and running currently is Wi-Fi. I am not connected to the wired LAN, right? Now you may actually say, why not the bridged adapter? And which can actually bridge over the airport interface, which in Mac is the Wi-Fi interface. Now I've tried a couple of tests and it looks like when I use bridged adapter over airport, it doesn't work that well. And with NAT, well, everything just works fine because VirtualBox takes care of all the IP addressing and the NATing and all the other intricate details. So this seems to be a configuration which just works practically out of the box for us, and we will use this. So now, once I have set it to NAT and to use basically any available interface, VirtualBox will actually use my Wi-Fi connection to NAT the Backtrack 4 R2 instance to the rest of the network. Now let me actually bring this on. Let's bring Backtrack up. While it is coming up, this is where all the fun things are going to start now. And if you're just curious what's next, In the next video, we will look at SSL MITM attack, in which we will actually serve to an SSL enabled website and conduct an SSL man in the middle attack, where we will get things like passwords, etc. When any victim sends it to an SSL enabled site like Gmail or Yahoo Mail or wherever, right? So that will be a lot of fun. And in your comments, if you have any special cases you want me to kind of demonstrate, do let me know. I'm always happy to do so. Let's just momentarily wait for this to come up. I'm really enjoying making this series and hope you're enjoying watching it too. Okay, so now I'm inside VirtualBox and here is the various interfaces. By default, of course, Backtrack doesn't bring up any interface. So let's do the following. If we kind of go back to our little presentation, we first needed to bring up ETH0, which would actually be mapped via NAT to the Wi-Fi interface which connects to Vivek, which is this part, right? So let's do the following. Let's bring up ETH0. Currently, I'm not assigning any IP address. And what we will do is, in another terminal, we'll kind of orchestrate the next part of the hack, which is to bring up an access point with the SSID security tube. Right, so we'll use our friend Airbase NG and we will run this on, for the time being, we'll just give the minimum options here. Oops, the device itself is not up. So let's bring up WLAN 0 and then we will also create the Mon0 interface. Right, and now what we can do is, before we start the access point, let's actually set this access point on channel 1. Right, and now let's start Airbase NG, which will just become an access point on channel 1. Right, this access point has the SSID security tube. Now the next thing we need to do is actually bridge both of these interfaces, if you remember. Now from previous videos, what we know is, when we bring up the Mon0 interface with Airbase NG, there is a tap interface which is created called AT0, and this acts as the wired side of the access point. So we need to bring up this interface as well. And now the next step is actually to bridge both of these interfaces. So how do we do that? So we use a little utility called bridge control, BRCTL, and ADD-BR is create a new bridge, and let's call it demo. Actually, let's call it MITM, more apt. So this actually creates a bridge, and currently, if you notice, under interfaces, no interfaces have been added to this bridge, right? So now let's add an interface by saying brctl add if, and then we can say ETH0 would be the interface. Sorry, I need to name the name of the bridge here, MITM ETH0, and then similarly you have AT0 as the other interface. Let me once again just quickly bring up all these interfaces and actually assign them an IP address of all zeros. Similarly, let's do for AT0. And let's now bring up the bridge interface. So if you notice, what has happened is, this is actually a new interface now called MITM. If I do an if config -a, you will notice a new interface called MITM has been created, and this is nothing but a bridge which is going to connect the AT0 interface with the ETH0 interface. Now by default the MITM interface will not be up, so we'll have to kind of bring it up ourselves. Now we need to assign an IP address to this interface, just to ensure that we can do a lot of activities on it. It's not a requirement per se, but it would be a good idea to do so. So what we can do is we can actually run the DHCP client on this interface, right? And if you notice, VirtualBox has actually given us the IP address, right? So if I actually do a ifconfig MITM, you will be able to see that the given interface is 10.0.2.15. Awesome. So the stage is set, and now it's time to invite our host, which is the victim, right? So let's kind of bring up our victim. As always, our handy little victim is going to be our iPhone. So here we go, searching for the network. Let me kind of dim it a little bit. I think it's already connected to SecurityTube, right? If you notice, it's connected to SecurityTube. Now interestingly, this time an IP address was automatically allocated over DHCP. Can you see that? 10.0.2.17. The IP address was allocated by the VirtualBox server. Now, if you kind of remember our entire setup, here is what is happening. We actually have the victim connected to the hacker box, which in turn is connected to the access point Vivek using the inbuilt chipset right now. And because of the bridge, all traffic which the victim will send us is going to be transparently sent over this bridge. So let me do the following. Let's start a little bit of a sniffing exercise to actually check whether this is true. So let's open up Wireshark. And on my phone, I'm going to open up my Safari browser. And this time the interface we'll still continue to sniff on is AT0. Why? Because any traffic which goes and comes to the client will have to be from this particular place only. This particular interface only, right? So we started sniffing on AT0. Now I'm inside Safari and I'm going to type in google.com. Right? If you see, it's already kind of suggesting google.com on the top. So let me go ahead and add that as this. And if you notice, it's actually sending data, but over Wi-Fi, which is actually through our MITM setup. Awesome. Right? And we can verify this by just quickly looking at this traffic and filtering for HTTP. So if you notice, a GET request has gone, and this would be for google.com as expected. Now, if you really wanted to go ahead and spy on what traffic this phone is sending, it's very simple. Why? Previously, we had to sniff the air on a particular channel and just hope that any packet which is sent by a phone, maybe in clear text, over Wi-Fi would be visible to us and we would be sniffing the channel at that time. Now, any packet which this phone is sending to the internet has to go through us, the attacker, because it is connected to us. And this ensures that we are never going to miss a single packet. Right? So let me restart the sniffing very quickly and we'll notice something very simple. What I'm going to do is I'm going to type in securitytube.net as the search key phrase, and you will actually notice that the Google Suggest application would start working in the background over Ajax, and all the SEC or anything we type in would be going in plain text. So have a look at this. You're going to be typing in ECURITYTUBE, and then we have a little dot net, and then I'm going to say search, right? And search for securitytube.net is happening. So you see a lot of data here. So if we stop it, we've just kind of reverse engineered the Google search page. If you notice, Google has this Google Suggest Ajax based application which sends every keystroke the moment you type it into the form, and it gets a response with suggested possibilities to show to the user. So as an example, if you very closely look at this string, I can go here, Q is equal to S. This is the first letter we typed in. Now if I go to the next request, you will actually find that this has been modified to SE, and then SEC, SECU, and so on and so forth till the time we have actually typed in securitytube.net. And post this, basically the actual request went through. And if you notice, even the URLs are different. Get m suggest is for suggest, and get m search is actually for the real search, right? And the data went through, and all the data has come from the server. Awesome. Some of you may have tried this before, but I mean, MITM is like the holy grail of all attacks. And here is the beauty. As far as the phone is concerned, if the hack is done properly, it has no way of knowing something is wrong. Absolutely no way. Right? And you could just practically like view anything over the phone, and it would just work transparently, as you would kind of want it to. And I mean, I'm always thrilled. So right now I've kind of clicked on one of the links for tools.securitytube.net. If we were actively sniffing, you would actually see a lot of packets coming and going for tools.securitytube, and now the tools page is open, right? So let's go back to our slides and understand what we did. So here was our challenge. We basically had to have two Wi-Fi interfaces. One is actually connected to the authorized AP or some AP which will give us a stable internet connection, and the other interface is what is going to lure clients to connecting to it. Now that may happen with the DAuth attacks in the hotspot case. That may happen by actually monitoring the probe requests sent by isolated clients and bringing up an access point to match one of those SSIDs the client is searching for. Whatever the way it might be, once the client connects to us, we bridge both of these interfaces. And once the bridging happens, any data traffic which the client sends is sent to the internet via the hacker machine, and vice versa. Now, I would really encourage you to try a lot of these other configurations as well. This configuration is almost exactly what we have done. The only difference is that instead of connecting to a third AP, the hacker connects to the authorized access point, right? And this is a little bit different, where I guess the main thing is your GPRS 3G, 4G, if you have the right drivers, it is nothing but another interface which will show up in ifconfig, and you need to create a bridge with the AT0 interface, and the same thing happens, right? Now, some of you may also point out that we could have actually used IP tables to do a lot of this stuff, the masquerading and everything. Absolutely, you can. There is no hard and fast rule about what you should use to actually bridge these interfaces. I just leave it to you. I find the bridge BRCTL set of tools much more fast and easy to kind of quickly do it, and not really changing the way my PC intrinsically behaves, right? And also the beauty with the BRCTL and things like that is you don't need to worry too much about, kind of removing many of these ACLs later on and things like that, which if you use IP tables, you would need to remove it for normal functionality later on. Anyway, that brings us to the end of yet another video. Hope you enjoyed this video. In the next one, we will look at SSL, man in the middle attack, which is actually going to now mangle packets and modify packets to take advantage of the entire MITM scenario. So, like always, please leave your comments behind. I absolutely enjoy reading them and hope you're also enjoying watching this video. I'm getting a lot of email. I'm going to reply to each one of them. So if you have anything you'd like to discuss with me in person, please send it. If you have a general query, comments would be better, because that way what happens is a lot of other people can benefit from your queries. But please write to me, tell me how you feel about this mega primer. I would really love to know you in person if you're actually watching all of these videos, right? Okay, thank you, bye bye.